Hi, Daryl Wittenberg here with Industrial Solutions and Redi2Weld. I'm really excited to show you something that we've developed on our welding systems that was really a response to what our clients have been asking for. We have traditionally given these systems out with a linear oscillator and then a arc voltage or an arc gap control system on this slide right here. But many of our clients were actually wanting to have more of a pendular oscillator that would really kind of resemble manual welding if you're walking the cup. And so we worked on this a little bit, and now we are really excited to bring this to the market. We're the only one in this section of welding automation that offers you pendular oscillation, linear movement, and then also arc voltage or arc gap control, all in one setup. So you have a tremendous amount of flexibility while you're welding. The way this works, I'm going to grab the remote pendant here. So if you look at the torch, I can raise my torch up and down right here. So while we're welding, we're going to be sensing that arc gap, and we're going to automatically adjust for ovality in the pipe. The operator doesn't have to account for that. We're going to be welding in TIG on this first weld, so that's going to be a voltage sense. We're going to set a voltage that represents an arc gap. If we were in MIG mode, we would set a current sense, and that current would actually represent an arc gap. So we can raise that up and down right here. That's one axis of motion. And then if I want to have that pendular oscillation like I was talking about, I can rotate this, and it's not a really fast rotation, so you can see that moving kind of slowly. And then we can come back. And so while it's welding, it will actually be welding, moving at a designated speed. So typically you would see us that we're going to hold the one side wall for maybe 0.3 of a second. We're going to transfer across the middle and hold to the second side wall for 0.3 of a second. Then we would also set a value for how much time we're spending in the middle or the excursion. So we've shown you the axis that controls the arc gap, and we've shown you the axis that controls our pendular oscillation. And now if I want to steer, I can do this right here. Let's say that the pipe was not mounted into the chuck squarely. And so now we have a bit of an ellipse that we're welding. This gives me the ability to steer while I'm welding, and I don't have to be afraid that I'm not going to be perfectly aligned with the joint all the way around. So having this flexibility right here, nobody else in this market offers this. Most of our competitors don't even offer a TIG option. This system can go both TIG and MIG. So we give you all this control at the torch. And then if you want to switch from MIG to TIG, that is extremely simple. You simply unlatch right here and pull this out. When I'm going back to that, I put it right back in and latch that in. Here's my MIG torch. I simply would pull this out and slide it right back in that same bracket. To switch from MIG to TIG literally only takes about 30 seconds. So this is a demonstration unit that we've built for our showroom. So it's not nearly as big as what you would see in production. But this headstock, just like the ones we would have in production, has up and down mechanized controls so that if we need to adjust the center line to adjust for a larger OD or smaller OD pipe, or for the branch connection coming off the pipe, that is a motorized axis as well. And then if I want to use this as a positioner, I've got a foot pedal here, I can rotate this around. So that gives me the ability, if I have two headstocks, one of them parallel with the other, while I'm welding on headstock A, I can have a helper loading and unloading the other headstock and also dressing the tacks down so that we can reconsume those when we weld. So what we're going to do is we're actually going to do a TIG root on this. So we'll take this system right here, or this coupon right here. This is a 6-inch Schedule 40. We cut these on our Watts pipe profiler. So this is a flame cut end. This is not a machined end. We've tacked it together with roughly a 332 to 532 gap. And then we've thinned down those tacks so that when we come across them, we can reconsume them. So we've got this in here. We're going to start on a tack. We're going to use pendular oscillation to do the root pass. You'll see that in the arc view camera. And then we're also going to, after the root pass is finished, we're going to swap out the torch and go to a MIG fill and cap. This will give you an idea of literally how long it takes to go from TIG to MIG on the R2W-3 combo system. So Samantha's already over there at the control panel. I'm going to step over there and we're going to get this weld going. So Samantha, when you're ready, we can strike the arc. So we've got a Xyrus arc view camera, and so she can see what's going on in the weld, and you can look right down in that groove and you can see that we're consuming the edge of that bevel and we're bridging that opening. And then if she needs to make adjustments while she's welding, she can do that simply by adjusting either the width, the travel, or the dwell times. She can do all of that with her remote pendant. Then if she wanted to make some changes on the program while on the fly, if the welder is given the opportunity to do that or the permission to do that in our system, they can make those changes on the fly as well. So while Samantha's welding with this, you can look right there at the edge of those bevels and see how it keyholes. That's what we're looking for. We want to see that keyhole appear so that we know that we're consuming the edge of the bevel. The other thing I want you to notice as we come into this tack, we're going to reconsume this tack. There's a ramp that we grind into it as we thin it down. And then as that tack rolls through, you're going to see it really wash away, just like that. So again, by giving you pendular oscillation, she can adjust the width of her oscillation, and then if she needed to steer right to left because the joint's not in there straight, she has that ability as well. You can really see from this angle that not only are we consuming the edge of those bevels, but we're getting good penetration to the inside and reinforcement. We're not going to be too heavy, but we're definitely going to be above flush. The penetration on the inside is very consistent. We also have the ability to purge through the chuck. So if we were doing an alloy, stainless steel, titanium, Inconel, any of those alloys that require an ID purge, we can actually purge through the ID on this, and that way you can control that solenoid from the control panel as well as your shielding gas. When we go to the MIG side, we actually give you two solenoids to choose from there as well, because you may want to run 75-25 for your root and then switch over to 90-10 for your fill and cap so that you can be in spray mode. We give you that flexibility so that you can adjust those things on the fly and you don't have to stop. You can keep welding from root to cap. Nice, consistent. Now, when you look at this root, it's actually going to be heavier than what you would see manually. So if we were to weld this all the way out as a MIG weld, as a TIG weld, we could still do this in 2 passes. But since we're going to swap out after this pass and we're going to do a MIG fill and cap, you'll see the system shut down at the end of the root pass. Again, the inside's very consistent. Edge of the bevels are all consumed. and we don't have to worry about there being a lack of fusion. We can see that we've got penetration and reinforcement on the inside. So stepping back over here where Samantha is, you can see on the system there that it says we're about 90% done. The reason it says that, this is a one-pass weld for us since we're only doing the root. And the thickness of this is actually equivalent to a root and a hot. So we have a downslope. And now we're going to swap out between the MIG and the TIG torch. So now that we're done with our root pass, you're going to see Samantha changing the program on the HMI. She's going to select a 6-inch Schedule 40 program that has the fill and cap pass that she's looking for. She loads that, and then she will change the system from MIG to TIG mode up in the right-hand corner. She checks her gas to make sure she's got the right gas. And that program is set up for MIG. And now we're going to watch her as she changes out the torches. So she takes the MIG torch, releases it from its holder, and she'll release the TIG torch that is currently in the column and boom on the welding end, and she'll load it in the spare holder that's on the column. And then she will load that MIG torch into the oscillator. That drops into place. Now that's actually a robotic oscillation or a robotic torch holder that we have adapted for this. It works really well, gives you a nice rigid mount, and at the same time it gives us a great area to mount that Xyrus camera that we're using for the arc view. That Xyrus camera is water cooled, by the way. We're keeping that camera at a really cool 31 degrees Celsius. Now remember, we just did that weld. So it's pumping water through the housing that holds that camera the whole time. So again, on this demonstration unit, it's a manual adjustment for the over center for that boom. If this were one of our production systems, that's actually a mechanized or a powered slide. So now Samantha's back over where she wants to be. I'm going to turn the picture-in-picture back on so that you can see the arc whenever she strikes it. She's looking through the program. She's going to validate that it has what she's looking for. And then when she's ready, she's going to strike the arc. So with this EWM system, we're actually using a waveform that is called force arc. And if you'll notice the view of that arc, the cone of the arc is very vertical. It's not spread out like you would see in a lot of pulse spray modes. Force arc really directs the energy of that arc, and so you have really good sidewall fusion. We're able to fill and cap in one pass on this. She is currently rolling at about 7 inches a minute, 6 3/4. She's running 215 inches a minute of wire. Her heat input is only in the 30 kilojoule range. So still welding pretty cool. Her current is at 150 amps. Now again, we're monitoring that arc gap through the current. And so she is able to ride right through any ovality that might show up in that pipe. So giving you a side view of the system, as it rolls out, we're able to really monitor the oscillation width through that camera. And I'm going to go take a look at it right here. We're above flush. We've got a nice consistent weave and a really consistent cap pass going on there. So again, the benefit of this is we're actually welding cooler than you would be typically by manual welding methods. And so on our screen there, it actually gives us the heat input. She is currently running at between 27 and 30 kilojoules. If she wanted to adjust the oscillation width or the dwell time, she can do that. The system is telling us that we're 75% complete. I want you to pay attention to the tie-in when we get back around there. It'll be in just a few seconds. We have a downslope. It knows where it is in the tie-in, and we automatically downslope and give ourselves the nice smooth transition before we turn that arc off. So here comes our tie-in. We're at 95%. Got a little bit of an overlap, and then we shut down. So we've completed that weld. We'll turn that picture-in-picture off. And you can see that we've got that pass in nice and consistently. That joint next to us, that's just a root pass that we put in with the TIG system previously. And there's our tie-in. Roll that back the other direction if you would, Samantha. Our foot pedal gives you both forward and reverse, so if you're working with this and you're loading and unloading a system, it gives you the ability to load and unload on one power supply or one headstock while your operator is welding with the other. So thank you for watching this video today. Our goal was to show you that we can take a system like this and we can give you MIG and TIG capabilities in a package that's operator friendly, much more competitively priced than others that are on the market, and give you a tremendous amount of flexibility in the jobs that you would take on. If you're doing a job that was TIG only, this system can do it for you. If you're doing a job that maybe you want a hardwire root and then a flux core fill and cap, again, this Redi2Weld system can do that. Or possibly you want to go with a TIG root and then a hardwire or flux core fill and cap. The flexibility with this is unparalleled in the market. It's very user friendly. The install really only takes about 4 days, and then training is about another week. I really appreciate you giving us your time today, taking a look at this video. Please reach out to us at our website, isi-llc.com, or give us a call at 281-824-0356. Let us help you achieve your goals in your weld production. Let us introduce you to Redi2Weld.